Today I'm gonna talk about the limit of division of two polynomials, specifically for the indeterminate form, and we're gonna use L'Hopital rule to solve this indeterminate form. So before we solve these examples, I'm gonna talk a little bit more about L'Hopital's rule. So if fx divided by gx at x equals a belongs to 0 over 0 or infinity over infinity, then we can use L'Hopital rule. Okay, L'Hopital's rule is here. Basically, what are we gonna do? We do the derivative for the numerator and the derivative for the denominator. Okay, and we needed to know the condition for using the L'Hopital's rule is 0 over 0. Okay, or infinity over infinity. 0 over 0 we call the indeterminate form. Now let's take a look. The first example. As we know, when we plug in x2 in this rational expression, we can get what? We can get 0 over 0. Okay, 0 over 0. Now we can tell that belongs to indeterminate form. Okay, then we can use L'Hopital's rule, and for this guy gonna be x approaches to derivative for the numerator and derivative for the denominator. Okay, and for the numerator we're gonna use the difference rule, because x minus 2 derivative of x minus 2, that means we're gonna do the derivative for each term. And similarly, derivative of x squared minus 4 gonna be a derivative of x squared subtract derivative of 4. Okay, that's a difference rule. And now we're gonna use power rule to calculate the derivative of x and the derivative of x squared. As we know the power rule, I'm gonna record the power rule here. X to the power n derivative prime equals n times x to the power n minus 1. Okay, so here derivative of x, n equals 1, plug in 1 here, 1 minus 1, x to the power 0, that is 1. Derivative of constant is 0, and the derivative of 2x, follow the power rule, you're gonna get 2x, and the derivative of 4 is 0. Okay, now you can plug in x equals 2, that'll be 2 times 2, 1/4. Okay, again, let us address the second problem. Now follow the strategy. We'll plug in x equals 1 in this rational expression. We're gonna get what? We're gonna get 0 over 0. So that it belongs to indeterminate form. That means we can use L'Hopital's rule follow the steps. We're gonna do the derivative of the numerator and over derivative of the denominator. Okay, and then here we do the derivative of trinomials. That means we're gonna do the derivative for each term. Okay, difference or sum rule. Okay, for each term. And for the denominator, very similar. We do the derivative for the x, do the derivative for the constant 1, and then we can simplify it. Okay, so for this guy we're gonna use power rule, 2x, and the derivative of 3x we can put 3 out of the derivative because the constant multiply the x, so that means 3 times derivative of x is 1, and the derivative of constant equals 0, and the derivative of x is 1, derivative of constant equals 0, and again x approaches 1, we have 2x plus 3. So we can plug in 1 here. You're gonna get 2 times 1 is 2, 2 plus 3 is 5. Okay? Now, let's try the last example. Now, when we plug in x equals -1 here, of course we're gonna get 0 over 0. Again, we know that is indeterminate form, so we can use L'Hopital's rule. So follow the steps. X approaches -1. We do the derivative for each term. Okay, and for the numerator we're gonna have x to the power 6 prime minus 1 prime. That is a difference rule. X to the power 4 prime 1 prime. Okay, and again we can follow the power rule. So power rule for the derivative of this guy gonna be 6 x to the power 6 minus 1, that is 5, and derivative for constant is 0. For the denominator, that is 4 x to the power 4 minus 1 is 3 minus 0. Okay, and then we can simplify it. X approaches -1, and 6 over 4 can simplify it 3 over 2, and x to the power 5 divided by x to the power 3, so we can get what? X squared, right? Because x to the power 5 divided by x to the power 3 is going to be x to the power 5 minus 3, that is x squared. And then we plug in the -1, that's going to be 3 over 2, x squared is -1 squared. Okay, and then we can simplify. -1 squared is going to be positive, so 3 over 2. That's it.